Hello, my name is Tom Peach. I'm with Campbell CV Company, and today we're going to talk about mechanical condensate pumps. Here's a typical mechanical condensate pump system that we have. We're going to notice a few key components. We're going to have a receiver tank. The receiver tank flows through some piping through an inlet valve, a check valve, flows into a mechanical pump. This is a PT206. The flow then goes out through an outlet check valve and then travels up the overhead piping, and we're just going to recycle this condensate back to the tank again. And the other thing we're going to notice is we have a mode of supply to make this mechanical pump work is going to be compressed air, so we have an air regulator. And let's see, the next thing we have would be called the exhaust valve. That's on the back side here. And I'll simulate all that with this prop cutaway that we have here. This is also a live system. And so what I'm going to do now is you're going to notice that the mechanical float basically looks like this. This is how it would operate upon the liquid level going up and down inside the pump trap. And what I'm going to do now is I'm going to energize this system. We're going to watch a live fill-up cycle, and then it's going to go through a pump down cycle, and then a fill cycle again. So let's take a look and watch this operate. I'm going to open up the water supply. You're going to see this pump flood rather quickly. It's going to get to the top assembly point where this float goes up, and you're going to hear a click. I can simulate the click as well. Now you're going to see that that float now is going down as we're batch pushing the condensate out. Back down again, and it's in off mode, and then it goes back to the fill mode. So what basically is happening here is right now condensate is flowing through the inlet check valve and flooding our pressure vessel. We opened up an inlet mode of air valve that's pressurizing this pot, and we're overcoming the downstream pressure of the lift back to the tank. But what happens is the inlet check valve goes to the closed position. So what we do is we batch force this batch of condensate, about 4 gallons, down and out through the outlet check valve. So we force 4 gallons of water out through the piping, back up and over, and 4 gallons back to a receiver tank that would be back in the boiler room. And the system continues to go through its cycling mode. Up, down, up, down. Now you're going to notice that right now this system is doing what's called venting. I can restrict the flow of condensate into the tank by restricting the venting. All that air pressure that we use to push this condensate out needs to be equalized and vented so that the thing can fill back up again. Now we can run these things on compressed air. We can run these systems on steam. We've got applications on nitrogen and other inert gases as well. Now I'm going to shut off the flow of condensate after the pump down cycle occurs. So we can shut off the noise associated with that. And now what we're going to do is we're going to look closer at the mechanical assembly itself. So again, we have a float. We have what's called a pivot point or mechanical advantage. In the top of the pump cap, we're going to have a 1/2-inch inlet valve, and we have a 1-inch exhaust valve. The motive gas comes in and pressurizes the underside of this chamber, pressurizes the vapor chamber, pushes the liquid level down. When the assembly gets to the bottom, you're going to hear it click and shut off. Shuts off the motive gas supply, opens up the exhaust valve, and then it's a dual purpose assembly. One valve's normally open, one valve's normally closed, and then they reverse the cycle when the mechanism goes in the upward position. So that's basically it. Very few moving parts, and these units last for about 3 million to 6 million cycles, which is a minimum guarantee of 3 years. So the technology has come a long way since 1969. And this is the basis of a mechanical condensate return pump. Thank you.